All right, today we're going to build off of the one-step mole conversion, go into two-step. So periodic table we're going to be using, and then we're going to be using our Heart of Chemistry conversion tool here. Okay, so same process as the one step, but just we have to take it one other extra conversion factor now. So first determine you're given an unknown. How many molecules, that's going to be your unknown, is contained in 3.5 grams of sodium hydroxide. That's our given. So given in the top left, 3.5 grams sodium hydroxide, NaOH. We don't know how many molecules that is. So to kind of see where we're going in this T-chart, we're starting at grams and going to molecules. So here's grams, here's molecules. There's no direct route between the two. So this is a two-step one because you have to first go from mass to moles and then convert that mole into molecules. So that's why this one would be called a two-step problem. So the first step is to go from mass to mole. So we're going to put the molar mass on the bottom to cancel the mass on the top, and then put the 1 mole on top. Okay? So I know right away 1 mole NaOH goes on the bottom. Grams NaOH goes on the bottom. I have to figure out the mass of sodium hydroxide. This is where you have to look at your periodic table. So here I need to look at the elements I'm working with. I'm working with sodium. I'm working with oxygen and hydrogen. I'm going to count the number of each I have. No subscripts or any of them, so it means I have 1 of each. And then I'm going to find the masses on the periodic table. So sodium is 23. Oxygen is 16. And then hydrogen is 1. So 23 plus 16 plus 1. So if you add those together, you get 40. So that goes right here. Okay, so you have to take that little step with the masses. Okay, grams matches grams, so they cancel out. Now we're in mole. We're trying to get to molecules. These do not match yet, so it means we have to do another conversion factor. Mole and molecules are not the same unit. Okay, so now we're in moles, and we're going to go to molecules. So to go from moles to molecules, to cancel out moles, we're going to put 1 mole on the bottom to cancel out the 1 on the top. And then we're going to put 6.02 times 10 to the 23rd molecules on the top. Okay, so 1 mole, remember we're going to have units diagonal from each other match to cancel each other out. 1 mole of sodium hydroxide is equal to 6.02 times 10 to the 23rd molecules of sodium hydroxide. All right, moles cancels out moles. We're left with molecules, which is what we wanted. So that means we're done setting up our T-chart. So here, we have to multiply the top numbers. We can kind of ignore the 1s because that won't change our answers. So here, theoretically, it's 3.5 times 6.02 times 10 to the 23rd. So 3.5 times 6.02. I'm going to do the second button, EE. There's my times 10 2 part right there. And then 23. All right, so that's the top number, that my total numerator. Okay, if you want to write that down, you can. You don't have to. That's easier for you to do the math. But here you can just say divide sign, and we're going to divide by the bottom numbers. Again, we don't need to worry about that 1. That's not going to change anything. So we're going to divide by 40. So divide by 40. There we go. And then our answer is going to be 5.27 times 10 to the 22nd. There we go. Okay. All right, that is like an atoms to mass or mass to atoms type problem. Now we're going to do like atoms in liters. Okay, so here, this type 2 type of problem, what would be the volume? So volume is going to be our unknown. If you have 2,500 atoms of nitrogen dioxide, NO2, so that's your given. Don't worry about the STP thing. The STP means just we know that for every 1 mole you have 22.4 liters. Okay, that's just a little extra info that we don't necessarily need for the problems we're doing here. All right, so given goes in the top left, 2,500 atoms of NO2. And then we're trying to figure out the volume here. Liters of NO2. All of our problems are going to be at SP, so that's why all of our problems are going to be using 22.4 liters. Okay. All right, so atoms to liters. Here's your atoms. Here's your volume, your liters. Again, there's no direct route between those two. So we have to first go from atoms to mole, and then from mole to liters. Okay, so first up, atoms to mole. To cancel out the atoms, we're going to put the atoms number on the bottom, 6.02 times 10 to the 23rd, and then we're going to have 1 mole on the top. So that's the conversion factor we're using for this one. So 6.02 times 10 to the 23rd atoms, nitrogen dioxide, that's the same thing as 1 mole of nitrogen dioxide. They're equal to each other. All right, atoms matches, so it means we've successfully canceled those out. We're in moles, we're trying to get to liters. So those don't match yet, so it means we have to do another conversion factor. So right now we're in moles, and we want to get to liters. So from moles to liters, to cancel the mole that we had, well, we're going to put mole on the bottom now to cancel it out. And then we're going to put 22.4 liters on top, so we're left in liters. So 1 mole of NO2, 22.4 liters on top. Moles cancel out. So to do the math here, 2,500, here we go, times 22.4. If you want to write this down, you can. 56,000. You don't have to write that top number down. And then we're going to divide by the bottom numbers, which we ignore the 1. It's not going to change your answer. 6.02. Second button, EE. So there's your E23. So your answer is going to be 9.3 times 10, or let's put 0 times 10 to the negative 20, because you're dividing by a very large number, so you're going to end up with a very small number. All right, let's do one more. All right, we'll do the second one here, the mass to liters type of problem. Okay, how many grams? That's your unknown. If you have 45.2 liters of gas, that's your given. Okay, 45.2 liters of CO, of just CO, okay, carbon monoxide. We're going to figure out the grams of carbon monoxide. All right, liters to mass. Okay, so here's your liters. Here's your mass. There's no direct route, so we have to do 2 steps. We're going to go from liters to mole first, and then from mole to mass. Okay, so from liters to mole, we're going to have 22.4 liters on the bottom, 1 mole on top. So 22.4 liters on the bottom of CO, carbon monoxide, for every 1 mole carbon monoxide. Liters cancels out, they match, okay? Mole of CO does not match grams of CO, carbon monoxide. So that means we have another conversion factor to do. So we have to go from moles to mass, moles to grams. So from mole to grams, we're going to put 1 mole on the bottom to cancel the moles that are on the top, and then figure out the molar mass from the periodic table, PT. The periodic table, we're going to use that to figure out the mass of carbon monoxide. So for every 1 mole of carbon monoxide, we know we're going to end up with grams of carbon monoxide. This is where we have to split apart your compound into its elements. We have carbon, we have oxygen. No subscript, so I have 1 of each.